Now then, that better? Right, so you Google Schoology, you join Schoology, you'll be asked for a course code. That's the course code there on the right. Make sure you do it as all capital letters, no small letters, all capital letters, and with a minus between the J and the W and the H and the K. So if you've any trouble, you can contact me at pjjsci@gmail.com. I'll repeat that again. My email is pjjsci@gmail.com. When you're asked for the course code, enter the code exactly as it's written. Then you will have access. Once you get access, you download the lesson to your own computer. When you do that, there are two possible things that can happen. One, you can be asked to enable editing. That happens in most computers. So if you enable editing, then that will allow you to save it to your computer. So that's the first thing. So enable editing if asked to do so. And then if you're asked to enable content, much of the content connects via the internet, so you'll need internet access to get the videos and so on, or not all of them, just some of them. Enable the content, and then when you've done, so that will be that warning, security warning, reference to external media objects have been blocked. So you click enable content and that will let you watch the videos. Then save it to your own computer and then you have it yourself. You can use it as often as you like and go over it time and time again. If you don't have Microsoft Office on your computer, all you have to do is download PowerPoint Reader and install it, and that will allow you to read PowerPoints even though you don't have PowerPoint on your machine. Now, okay, let's just talk about organic chemistry first of all. It's the study of carbon and its compounds. Except carbon monoxide, carbon dioxide, carbonates, and hydrogen carbonates. All the compounds in organic chemistry were found only in living things, and that's where the name organic chemistry came from. So they were thought to be very special, i.e. God had breathed life into them, and of course, that's a matter of opinion, but when a compound called urea was found in urine, it was synthesized by Frederick Wohler, way back in 1828, and that turned chemistry totally on its head. It showed that these molecules that we thought were special were no different to any other molecules. They could be made in the lab if you could get the right process. Right? So there's urea there. You don't have to know its formula. But it's a nitrogen-containing compound. It's an excellent fertilizer, and as we say, it comes from urine. Right? So this showed that they were the same as any other chemical. Now, organic chemistry is by far the most important section on the course. In previous years, you could pretty much pass the exam if you knew your organic chemistry perfectly. Now you can actually get, an H3 using if you get all your organic chemistry correct, possibly even more. So it's even more important nowadays. Right? So there are 3.5 questions out of 8 in a normal year. That's 3.5 plus questions out of 6 now. Right? So that's a big jump. The layout of the paper is going to be pretty much the same, so it's pretty fair to assume that question 2 has always been the organic practical or organic experiments. Question 6 deals with the fuels, that's the alkanes, the alkenes, and the alkynes. And at the tail end of that, a bit on thermochemistry. Question number 8, now not always question number 8, but usually question number 8 is a question dealing more with organic theory, not organic practical, but organic theory. And in questions 10 and or 11, there's sometimes half a question or more on organic chemistry. And on top of that, some bits of question number 4, which I call the short questions, where you have to do 8 out of 11. There are parts of that. So it is very, very important. Right. Let's see, we'll display now.
Hey, this is Mr. W from Science Music Videos, and this video focuses on carbon, the central element in living things. As you learn biology, you'll learn about molecules like phospholipids that make up membranes, like DNA that stores genetic information, and like hemoglobin, which transports oxygen. All of these molecules are based on carbon. Here's why. Carbon is element number 6 in the periodic table. It's number 6 because it has 6 protons. It also has 6 electrons, and in the most common isotope of carbon, 6 neutrons. Think back to the octet rule. The first 2 electrons go into the first orbital. That leaves 4 outer or valence electrons. Those valence electrons readily form covalent bonds. If you need a review about covalent bonding, go to sciencemusicvideos.com. The link is right below. Here's carbon forming 4 covalent bonds with 4 hydrogen atoms to form methane. If you can form 4 covalent bonds, you can form chains. You can form rings and also branched molecules. Here's another thing about carbon. With 4 valence electrons, it easily forms double bonds and even triple bonds. This is a chain of amino acids, which are the building blocks of proteins. Notice the repeated double bond between the carbon and the oxygen. It's the basis for one of the chemical interactions that causes this protein, hemoglobin, to fold up into its specific shape. And that makes its function, which is carrying oxygen, possible. It all comes down to carbon and its 4 valence electrons. What's the takeaway? By weight, we're mostly water, but carbon is what makes possible the molecular complexity that life is all about. Right now, go to sciencemusicvideos.com, do the tutorial about carbon. You do have to purchase a subscription, and it's incredibly reasonable. It's more than worth it. Do it. If you're part of a class that's not using sciencemusicvideos.com, then when it's appropriate, talk to your teacher, talk to your professor, have them contact me, and we can talk about setting up a site license. Final challenge. There's another element that has 4 valence electrons.
Now guys, I'm going to go to the end of that and hope that I can move on to the next one.
I'll give you your
come on.
Challenge. There's another element that has 4 valence electrons, and it's been the topic of a science fiction series episode.
Sorry about this. Oh, here we are, right. Okay, we're going to talk about things called homologous series. Homologous series, in simple terms, chemical families, but we call them homologous series. It seems much more scientific than chemical families. There's a little video there, you can watch it. It's just a music video. So the whole point about homologous series is they make the study of organic chemistry easier. Like families, they have things in common, but they're not identical. Once you know about one member of a series, you can predict the properties of the other members of the series. That's the key about it. And all the members of each homologous series have 6 things in common. We're going to go through the 6 of them one at a time and expand on them. The first thing is that they have what we call the same general formula. Now, general is an important word, not chemical, not molecular, general formula. The 3 that are most important are the alkanes, the alkenes, and the alkynes. And you can see that there's an N for the carbons. That's the number of carbons. It's always a whole number. And in the alkanes, there are twice as many hydrogens +2 as there are carbons. In the alkenes, there are twice as many hydrogens as carbons. And in the alkynes, there are twice as many -2 hydrogens as there are carbons. So if something is made up only of carbon and hydrogen, that's a hydrocarbon, we call it, consists of carbon and hydrogen only, then you compare the number of carbons to the number of hydrogens, and that will tell you which of those three groups it belongs to, and therefore it will tell you how it reacts with what. Another group is the alcohols, which are generally CnH2n plus 1 OH. So I suggest very strongly that you learn those general formulae. Right? N is any whole number greater than 0, apart from in the alkenes and the alkynes, where it is 2 or greater. Right. The second thing is that each member of a homologous series differs from the one before it and the one after it by 1 carbon and 2 hydrogens. We describe that as differ by CH2. CH2. There is methane, CH4, we saw that earlier. Then following that, the next one is ethane, and that's the difference between the two of them is CH2. The next one is propane, and the difference between that and the previous one is CH2. So each one differs from its neighbour by CH2. Very simple, very straightforward. The third bit is the most important bit of all, and that is they have what we call the same functional group. What do I mean by functional group? It's the group of atoms that gives the homologous series its main characteristics or properties. Let's look at the functional groups that you have to know, and we'll go through them one by one. You have to be able to draw their structure. You have to be able to recognize them in chemical formula. For example, OH is a functional group of alcohols. If you drink an alcohol, the bit that makes you drunk, and if you drink too much will kill you, is the OH bit. The hydroxyl group it's called. All right, so we're going to start off with the alkanes, the alkenes, and the alkynes. That's the hydrocarbons. Right? The first three groups are called hydrocarbons. A hydrocarbon is a compound made of the elements carbon and hydrogen only. Now, the exact order of the words doesn't matter. You could say it's a compound made of only carbon and hydrogen. That's perfectly acceptable. You don't have to put in the elements, but that would make it absolutely precise if you did. Asked frequently. A hydrocarbon can only be A, an alkane, B, alkenes, and C, alkynes. And that's where you revert to your knowledge of the general formula to see which one it is. Right? The general formula tells you which one. Right, so we're going to start with the alkanes. All alkanes end in ane. That tells you the family. So all end in ane. The general formula, as we said a moment ago, was CnH2n plus 2. So there is the second member with 2 carbons, C2H4. Notice I haven't put in the H's. There's no need to put in the H's. We assume that at the end of each bond, there is an H unless something else is put there. And the key here is that all the carbon-carbon bonds are single bonds. So an alkane is a hydrocarbon where all the carbon-to-carbon bonds are single. Now notice I said all the carbon-to-carbon bonds, not all the bonds, but all the carbon-to-carbon bonds are single. And obviously methane can't have a carbon-to-carbon bond since it only has 1 carbon. So here we have the first 4 alkanes. CH4, add CH2, you get C2H6, add CH2, you get C3H8, add CH2, you get C4H10. The names are methane, ethane, propane, and butane. So they all end in ane. That tells us they're an alkane. So what does the first part of the name shown there in blue tell you? It tells you how many carbons the compound has. And you need to remember it's called a prefix, right? The prefix and what the prefix tells you. Methane, ethane, propane, butane, pentane, hexane, heptane, octane is as far as you have to know. Right? So the number of carbons, the prefix that goes with it, if you've one carbon, it's either meth or methan, 2 carbons, eth or ethan, 3 carbons, prop or propan, 4 carbons, bute, 5 carbons, pent, 6 carbons, hex, 7 carbons, hept, and 8 carbons, oct. Now you have to remember that. The hard bit are the first 4. I mean, pent, you get a pentagon, the 5-sided building in America. You get the hexagon, a theatre. You get a heptathlete who does 7 different disciplines, and an octagon, an 8-sided figure. The way I remembered them was to use a little mnemonic. Many English people buy pretty horrid houses often. So any of those, any mnemonic you want to make up yourself, you can do it. That's the way to remember. It's absolutely vital that you learn that. There's methane, CH4. There is ethane, C2H6. I've put in the hydrogens this time. Takes a lot of time. No need to do that. Propane and butane. Pentane, hexane, heptane, 7 carbons, octane. So those are the structures of them. If you're drawing them, don't waste time putting in hydrogens, just put in the bonds. So there's no need to put in the hydrogens, this saves time. You only have to put in other atoms that are not hydrogen that join to the carbon. Each carbon has 4 bonds. Always remember that. Each carbon has 4 bonds. If you draw the structure of a molecule, check your carbons all have 4 bonds. In the alkanes, it is 4 single bonds. Right? So, if we look at the simplified diagrams, there's methane, ethane, and pentane. Right? Now, if I had to use a model, that's what the methane would look like. 1 carbon and 4 hydrogens, that's a tetrahedral shape. Ethane is CH3, CH3, so we can write it as CH3, CH3, or we can write it as C2H6. If we go up to pentane, it's a straight chain carbon atom molecule, but of course it's not straight chain, it's actually zigzag, but we draw it as a straight chain because that's a 2-dimensional representation. So we could write it as CH3, CH2, 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 CH3. That's its structural formula. It's condensed structural formula. It tells us the structure of it, or we could simply write it as C5H12. If we could see the atoms in the molecules, they would look something like that. Obviously not those colours. We just simply use black for carbon as a matter of course, and white to represent hydrogen. They're neither black nor white, although carbon in total is black if you get a lot of them. So those are called stick models, and the bottom ones are called electron clouds. Electron clouds. Right. So we can make it even simpler. I can show ethane as simply a stroke. I can show pentane as 4 strokes. How can I do that? Well, if everyone accepts that at the end of each line there is a carbon atom, carbon and carbon, and that each carbon has got 4 bonds. Therefore, there's a carbon here at the end. It's got 4 bonds. There's one. So the other 3 are 2 hydrogens unless stated otherwise. So that's a much simpler way of doing it. You don't have to know it, but you're entitled to use it if you want to. Right? The carbon at the end of each line, hydrogens assumed to make up the rest of the 4 bonds, but they're not shown. Now, each carbon has 4 bonds. Remember that. Always check, count them. It can have 4 single bonds. There it's got 4 single bonds. Or it can have 2 singles and a double. There's 2 singles and a double here, and 2 singles and a double here. Or it can have 2 doubles, as in carbon dioxide. It's got 4 bonds there, 1, 2, 3, 4. Or it can have a triple and a single. For example, here we've got ethine. Well, it's got 3 and one's 4. This one has got 3 and one's 4. So that's one option. And while we're on it, if you're talking about oxygen, oxygen always has 2 bonds. It can have 2 single bonds, as in water. 1, 2 single bonds. Or it can have 1 double bond, as in carbon dioxide. Each oxygen has 1 double bond. Those are very important when you're drawing structures, to remember that. Other things like fluorine, chlorine, bromine, and iodine all have single bonds. Only 1 bond they can make. Right? So that's the alkanes covered. Now let's talk about the alkenes. The alkenes. The general formula is CnH2n. Right? And what do they have? Their functional group is they have at least 1 carbon to carbon double bond. Right? 1 carbon to carbon double bond. If there's 2, they can have 2, they can have more. But if they've got 1 carbon to carbon double bond, they're an alkene. If they've got 2, they would be called a diene. If they've got 3, they would be called a triene, and so on. Doesn't apply. You only have to know what's there. Right? The first member is ethene. So again, they all end in ene. The eth tells us there are 2 carbons, the prop tells us there are 3 carbons, and the but tells us there are 4 carbons. There is pent, hex, hept, oct, non, dec, and so on. You don't have to know those, only up to butene. So there's ethene, there's ethene, there's propene. We could write propene that way too. That's another way of writing propene. It's got a carbon to carbon double bond, and it's got 3 carbons, therefore that is propene. We could draw its stick model. There it is in a stick model. The next one is it's got carbon to carbon double bond. It's an ene. It's got 4 carbons, meth, eth, prop, butene. It's butene. Right? That's the logical way to do it. Look and see, is it a hydrocarbon? Yes, it is. Therefore, it's either an alkene, an alkane, or an alkyne. Which one is it? Count the number of carbons and hydrogens. Right? And again, carbon to carbon double bond, it's an ene. 4 carbons, it's butene. And again down here they've got hydrocarbon, 1, 2, 3, 4 carbons, 3 hydrogens, 4 hydrogens, 5 hydrogens, 8 hydrogens. So 4 carbons, 8 hydrogens, it's an alkene. With 4 carbons, it's butene. Stick model is there. The next are the alkynes. What's the general formula of the alkynes? CnH2n minus 2. It's got a carbon to carbon triple bond, a hydrocarbon with at least 1 carbon to carbon triple bond. Any compound containing a carbon to carbon double bond or a carbon to carbon triple bond is called unsaturated. And if you are asked to define unsaturated hydrocarbon, you must define the word unsaturated and the word hydrocarbon. Lots of people only do one. Right? So the first member of the alkynes is ethine. So we have ethine, propyne, butane. Again, the ine tells us it's a hydrocarbon with twice as many hydrogens, -2, as there are carbons. And the eth tells us there are 2 carbons, the prop tells us 3 carbons, the but tells us 4 carbons. These are all very basic things, but you have to learn them. Right. The alcohols. The alcohols have a functional group of OH. Now it's O single bond H, O single bond H. Most people just write it as OH, but if you're asked to write the structural formula of it, you must put in the bond between the O and the H. So there's the first one, that's methanol. Right? The next one is ethanol. And again, I've put in the bond between the O and the H. Right? An alcohol is a molecule containing at least one OH group. Now, it's not OH minus, it's OH, and it's O single bond H. So if you're asked for the structure, don't forget and put that in. This OH group is called the hydroxyl group. It's called the hydroxyl group. So this is methyl, it's got an OH, so it's an alcohol. Its name is going to end in all, 1 carbon methanol. An OH group, it's an alcohol, 2 carbons, it's ethanol. OH group, it's an alcohol, so 3 carbons, it's propanol, butanol, and so on. Now, let's look at this one. What kind of compound is this? Well, it's got an OH group, right? So it's an alcohol. The brackets around the OH, which you don't actually have to put in, tell me that the OH is attached to the carbon in front of it. You don't have to put in the full stops either. Right? So the H and the OH are both attached to that carbon. It has 3 carbons, so it's propanol. Right? In fact, it's propan-2-ol because the OH bit is on the second carbon. There is the structure of it up there in the top right corner. Right? The 2 tells us the carbon to which the OH is attached. It's attached to the second carbon. 1, 2, 3. So it's on the second carbon. Even this way, 1, 2, 3. The next functional group are the aldehydes. How do we know an aldehyde? Right? It ends in C double bond O single bond H. C double bond O single bond H. The first one there is methanal. It ends in CHO. So it's an al. It's got 1 carbon, so it's methanal. This one ends in CHO, so it's an aldehyde. And it's got 2 carbons, so it's ethanol. Right? So they have a CHO group at the end. Any formula written which has a CHO group at the end is an aldehyde. It's written as CHO to prevent possible confusion with alcohols. So if we look at this one, it ends in CHO, so it's an aldehyde. It's got 1 carbon, so it's methanol. This one also ends in CHO. It's got 2 carbons, so it's ethanol. This one ends in CHO, so it's an aldehyde. It has 3 carbons, so it's propanol. Right? Don't forget to count the C of the CHO when you're working out its name. The next group are the ketones. The ketones. They have a C double bond O in the center. They have a C double bond O in the center, right? In the middle. Certainly not at the end. The aldehydes, the C double bond O is at the end. In fact, in the carboxylic acids, it's also at the end. But in the ketones, it's in the middle, not at the end. The first member is propanone. If you're going to have a C double bond O, in the middle or approximately in the middle, you've got to have at least 3 carbons. So propanone, or acetone as it's called, nail varnish remover, right? So if we look at this, it's got a CO in the center. That tells me it's a ketone. It's got 3 carbons. It's propanone. It's propanone. This one has got a CO in the center. It's got 1, 2, 3, 4 carbons. It's butanone. And funnily enough, although this looks different, it's actually exactly the same thing. It's got a CO in the center. So it's an one. It's got 4 carbons. It's butanone. It's simply like having my pen. There's my red pen. That's exactly the same red pen. I've just turned it round, and that's the difference between those 2 formulae. Then the penultimate functional group you have to know, the homologous series you have to know, are the carboxylic acids. They all end in oic acid. Their names end in oic acid. Right? So when you look at the formula, they have a COOH at the end, a COOH at the end. The first member is methanoic acid, HCOOH. It's got a COOH at the end, so it's anoic acid. It's got 1 carbon, so it's methanoic acid. This is something you'll all have encountered either as nettle stings or ant stings, more likely nettle stings. But here we've got a COOH at the end. It's C double bond O single bond OH. That's methanoic acid. Right, so it's an ant and nettle stings. Ethanoic acid, you've all come across it. It's what we call vinegar. CH3COOH. COOH tells me it's a carboxylic acid. C and C, 2 carbons, so it's ethanoic acid. It used to be called acetic acid, and there's its structure. And you have to know the structure and this expanded structure and the condensed structural formula, right? Don't forget to count the C of the COOH when you're naming it. And now we come to the final functional group, the esters. And what do we have here? We've got a COOC in the center. COOC in the center. Right? So it's got a COOC group in the middle. So once you get COOC, that is an ester. Right? So HCOOCH3, there's my COOC. It's called methyl methanoate. Methyl methanoate. We'll deal with naming esters later. Right? Here is CH3COOCH3. Right? This is called methyl ethanoate. If you're asked for the properties or characteristics of an homologous series, say 1, same general formula, 2, same functional group, 3, differ from each neighbour by CH2. There are 3 other things which are very, very useful, but they're not what the inspector wants in the answer. So I'm just going to tell you them, but remember, those are the answers to that question. Right? Do not give the next 3 properties. They have similar chemical properties. Their chemical properties are similar, not the same, similar. Their properties change gradually with the length of the carbon chain, with the length of the carbon chain. As the carbon chain gets longer, they tend to become less reactive. Point number 5, they have similar physical properties. Right? Their physical properties change gradually also in line with the length of the carbon chain. Their melting points, their boiling points, their solubility, their density, and their viscosity. I wonder, do you know what viscosity is? Viscosity is thickness. For example, water is not viscous. It's very thin. It pours very easily. Honey is viscous. It's thick and flows slowly. As the carbon chain gets longer, their melting points and boiling points get higher, their density and viscosity increases, but the solubility decreases. They become less soluble, either in water, if they're soluble in water, and some are and some aren't. We'll discuss later which are and which aren't and why, or in organic solvents. And number 6, they have similar methods of preparation. We make them in similar ways. We make all the alkanes in a similar way. We make all the alcohols in a similar way, chemically at least. Right? So they're made in similar ways. We talk about making a meal. We talk about preparing a meal. Well, preparing sounds a bit posher than making, hence similar methods of preparation. These last 3 properties are useful to know, but don't give them as your answer. Now we will look at each homologous series and its chemistry in turn. Now, has anyone any questions on the functional groups? Anyone any questions on that?
Sorry, I was just on mute there. No, nothing yet. We have one question. Just wondering if you could pop the Schoology code up again at the end.
I will indeed. Yeah, no problem. If you remind me to do that too, Fian, please.
Yeah, no problem. And just a reminder, we'll probably finish up in the next 10 minutes as well, just to give people a chance to get across to do other classes.
Yeah, no bother. That's fine.
Perfect. Thank you. Yep. Anybody have any questions as well? Just a reminder, you can just go into the chat function, click on who you're sending it to, and you can send it to me directly, and then I'll let Peter know. I just had one actually come in there. Why should we not give those last few properties as an answer?
Because you won't get a mark for it. Simple answer, right? Now, well, you may not get a mark for it. It's probably a better thing to say. The first 3 are the 3 that are, if you look at the marking schemes, those are the 3 that are consistently there. The other 3 are correct, but the marking in chemistry is pretty tough. So you've got to give them the answers they want. In biology, which I mark, in fact, pretty much any correct answer will be taken. But in chemistry, it seems to be that only a correct answer is taken if it's on the syllabus and it's the answer wanted by the inspector. So you can give the other 3 if you wish, but my advice is not to give the other 3.
Cool.
Right, so some points for revision. You need to know what a hydrocarbon is, the difference between saturated and unsaturated, how to tell the number of carbons from the name, or learn the number of carbons and the name that goes with them, learn the general formula of the alkanes, the alkenes, and the alkynes, learn to spot the functional groups, learn how to write the chemical formula given the name and vice versa, be able to draw the structures up to at least 4 carbons long. Right? And here's a little test you can give yourself. I'm not asking you to do it now. You can do it yourself. Answer those, and then here are the answers. Here are the answers. So you can go through that and try it yourself. If you can do that and score highly in that, then you've covered this topic reasonably well. So I'm going to close that one. Now, Schoology. Here we go. I should have Schoology open already. No, I don't. By the looks of it, I must have closed it. Right, so it is open. Right, so you will join Schoology. That's the sort of thing you'll see when you join up. You'll ask to join a course, and I'll have to, and when you put in that, you'll get to Intel Chemistry, which will look a bit different to this, but it will have organic chemistry. This bit will be pretty much the same, and we're doing organic theory. And we're going to talk now about the alkanes, their sources, and fractional distillation. Quite a common topic. When you get onto it, you'll see the download symbol. There's the download symbol. You click in that. It will probably appear here in your one, and it will ask you to enable editing. I don't have to, because this is my own one that just comes up automatically for me. And there's the code. No, that's not the code, that's the wrong code. I'll have to go back and give you the code. I'm going to access, this is quite slow this morning, I suppose. Oh, here we are, right. I'll give you the code at the end. Right, so alkanes, alkenes, and mainly alkanes now, their sources and fractional distillation. General formula CnH2n, doesn't it rear its ugly head everywhere? The functional group is all carbon to carbon single bonds. The alkanes are our main source of energy. The sources of alkanes, there are three major sources. One is crude oil, which is fossilized remains of marine animals. Then there is coal, which is fossilized plant remains, and there is natural gas or methane or CH4, also called fire damp in coal mines. It's the source, its source is decomposing organic matter. Anywhere you get decomposing organic matter, in the absence of oxygen, you're going to get methane formed. I'm just going to skip that. Right. Now, definitions. Definitions are very, very important in chemistry and indeed in biology, since most of you will be doing biology. Definitions in general can be worth up to 20% of the marks in any given exam. So I'll give you a list of all the definitions for chemistry. There are, I think, 4 pages of them, just 4 pages. You learn those 4 pages, you've got 20% in the bag. Learn 5 a day, not a huge amount, time is running short now. Learn 5 a day, 20%, plus you'll get a lot more because all the questions use the technical terms. If you don't know what they mean, you can't answer the question. If you do know what they mean, it's much easier to answer the question. So here are some of the definitions here. We've had some of them already. A hydrocarbon made of carbon and hydrogen only. Saturated, only single carbon to carbon bonds, for example, the alkanes or the alcohols. Saturated compounds don't decolorize bromine or bromine water from red, brown to colorless. They don't decolorize acidified potassium permanganate from pink or purple to colorless. They don't do that. That tells you that any compound that doesn't do those two things is saturated. If it was an unsaturated hydrocarbon, such as an alkene or an alkyne, or any unsaturated compound, it contains at least one double or triple carbon to carbon bond, e.g. or i.e. the alkenes and the alkynes. These do decolorize bromine or bromine water from red, brown to colorless, or they decolorize acidified potassium permanganate from pink to colored, and you've got to use the word acidified. Now you can pick either of these two if you're given the choice, or you could be asked what would be the effect of an alkene being shaken with acidified potassium permanganate. Right? If asked to define or explain either saturated hydrocarbon or unsaturated hydrocarbon, each word must be defined. Aliphatic is a word I don't think you'll be asked, but aliphatic means it consists of chains of carbon atoms. These chains can be branched or straight. So a straight chain one, for example, there is octane, that's a straight chain. Right? There's another way of showing octane, this time showing the zigzags of the carbon atoms, but either one is absolutely acceptable, with or without the hydrogens. Again, if you want to do it the very simplest way, as lines, you can do that. right? Or they can be branched chains. This is a branched chain. How do I know it's a branched chain? Well, I can go along that chain without going back in my tracks. If I go up here and up there and then down, I have to go back in my tracks to get back online. So that's what we call a side branch or a substituent group. So the longest chain here is 1, 2, 3, 4, 5, 6, 7 carbons long. Or I can have a lot of branches. Right? There's a branch. I have to go back in my own tracks to get back online. This one was called 3-methyl heptane. Heptane because the longest carbon chain is 7. And methyl because it's got a CH3 group. A CH3 group is a methyl group. And 3 because it's on the first, second, third carbon. This one here is called 2,2,4 trimethylpentane. 2,2,4 trimethylpentane. What do all these molecules have in common? Well, they all have the same molecular formula, C8H18, but different structural formula. So anything that has the same molecular formula, that's when you just write down the different types of atoms and the number of the different types of atoms, nothing more. These are called isomers, and isomers appear very, very frequently on the Leaving Cert paper. So make sure you know about isomers. Here's a word that does come up all the time, and that word is aromatic. Aromatic. You need to know 2 aromatic compounds manufactured in Ireland, and you need to know what aromatic means, definitely. Right? You don't need to know their structures. I'm just going to show them. And you need to know that an aromatic compound, the first one I'm going to mention is aspirin. It's made in Ireland. There is the structure of aspirin in a stick model. In this case, the carbons unusually are shown in red. There's its molecular formula, C9H8O4. But we see here, this symbol here, this hexagon, that means it's a benzene ring. It contains a benzene ring, therefore it is aromatic. The name of the second compound is paracetamol. Right? There's the paracetamol structure, C8H9NO2. And again, there's the benzene ring. There it is in simplified form. So both of these are aromatic compounds produced in Ireland. Right? Now, naming the alkanes. If we take their name, their formula, right? Methane, ethane, propane, butane, pentane, hexane, heptane, octane. Right? Their melting points, look at their melting points. What's happening to their melting points? Well, their melting points are going up. Minus 57 is a lot higher than minus 183. And if I look at their boiling points, again, their boiling points are going up. And if I look at what state they're in at room temperature, I see that the first 4, methane, ethane, propane, and butane, are all gases at room temperature. Pentane is a liquid. Room temperature is 20 degrees centigrade. Pentane boils at 36. So if it was a hot room in the Mediterranean, pentane could boil. But in what we call room temperature, 20 degrees, it won't. And then those are liquid. When you get longer than carbon 17, they tend to be waxy solids. And remember, ane tells us it's an alkane. Meth, eth, prop, but, pent, hex, hept, oct tell us how many carbons are present. Make up your own mnemonic. That same one as I gave before. I used to have one that said, many English people bought pretty Heather Haythornthwaite $1 for O-level, where they had to learn the first 10. Right? Now, I think we'll call it a day at that for today, and we'll take up again at fractional distillation. If any of you have any questions on organic theory, perhaps at the start of the next class, I'll answer those before I go on to talk about fractional distillation.
Perfect, great. So yeah, if you want to, I'll send them to me tomorrow when the class starts. I'll get them across to Peter as soon as we start.
And I'm sure many of you have problems, you know, and I can't go through, I won't have time to go through the whole of organic chemistry with you. So if you have any particular questions you want to ask them and I'll answer them for you.
Brilliant. Thanks
Okay.
so much. See you all tomorrow.
See you tomorrow, Finn.
Bye.